So let's review a couple of traversal definitions on a binary tree. Now, we're not necessarily talking about binary search, but binary tree in general. Pre-order, in-order, and post-order traversal. So these are an example of depth first search. We don't do this laterally, we do it actually deep. It goes right in there. So three different types. One is pre-order. A pre-order allows you to visit the root first, the root of the node, right? So this is a top level. In order means that the root visitation is right between left and right, left being the first one. And post order means that we're going to visit root less. So this is left, right, and then root. Let's move on to the next page. If you recall in your binary search tree.java, the get iterator method is triggered by iterator. This iterator is it's an overridden method from your iterables, and this get iterator takes a enum. So enum for the traversal order type. If this is in order, then the get iterator is gonna iterate through the underlying buffer using in order. If this is a post order, you'll use post order. If this is pre-order, you'll use pre-order. So this is a snapshot of that methods here. The very first part is the traversal mechanism that eventually allows you to flatten, right, the tree into a queue. So this is just a different ways of flattening your tree into a queue. So this info queue is the one that gets passed in, and then we'll look at how we flatten this, right, using the in order, pre-order, and post-order later on. The second part of this thing is the anonymous class, because recall that iterator calls the get iterator, and the get iterator, actually, let me just move up a little bit here. I can see it. The iterator returns an instance of an iterator. So we're using this anonymous approach to construct an instance of an iterator that comes with has next, and remove. Recall that iterator is also an interface, right? So the fact that this binary search tree implements iterable requires the use of the override methods called iterator, which returns an iterator instance. And iterator itself is also another interface. So you got to implement these three abstract methods: has next, and remove. So anyway, and that's what this is. Let's move on to the next slide as we will see more on how we can flatten this from a traversal standpoint into a queue. So this is in order traversal. So as you know, as you see, the in order requires the visit of your root being the second part, right? So the first part is the left tree visit, and then the root visit, and then the right tree visits. So this is your code. If node is not null, then you proceed with these things. Now, instead of having the system output line to print the node info, we're queuing this out, right? So this allows us to apply, right, in order traversal to in queue, right, our node. As you see, because in order involves getting all the way to the left before pumping in the info, right? Because node is not null, it's going to keep recursing all the way through. So the very first elements that goes into your queue is going to be A, right? The second one is going to be D, and then J, right? And then going back to M, right? And then it's going to keep going down, right? The level to get your Q, get your R, and then T. So that would be the order of the insertions from the in order, right, perspective. So you can extrapolate this very easily, knowing how in post order and pre-order work. It's the same mechanism to flatten this out into a queue. You will have the in-queuing mechanisms in the appropriate place. Pre means instead of having a system output lines up there, you will have the queue, the in-queuing actions on top. And then for the post order, it means that in-queuing is on the bottom. So this is an alternative illustration of what we used to have as applies to binary search tree. So these are the traversal mechanisms on binary search tree.